Hello, abafundi sanibonani. So today we're going to be looking at the theorem of Pythagoras, and it's a really cool piece of mathematics, actually a very, very old piece of mathematics. Pythagoras was a Greek who lived sort of about 2,500 years ago, so a long time ago. Because cameras hadn't been invented, we don't have any photos of him, but this is often shown as a picture. This is obviously it's been carved out of stone around the time that he lived. Okay, so let's dive straight in. So what we're gonna firstly just look at the concept of area, all right, and we're going to work out area by counting squares. So each of these little squares the little squares like this one here in your workbook are 1 centimeter squared. Right, 1 centimeter by 1 centimeter. And that's what we call 1 centimeter squared. Okay, I'm going to just quickly hold up a centimeter squared just to show you what it looks like. Okay, so there it is. It's not very big. It's 1 centimeter that way by 1 centimeter that way. If you've seen a tennis racket, it's about the same size as the space on the strings in between the strings on a tennis racket. Okay, right. So 1 centimeter by 1 centimeter. Now, what we want to do is we want you to try and count the area of each of these shapes. So this one's very easy, 1, 2, 3, 4. This one is 4 centimeters squared. Some of them are a little bit harder because you're going to have to try and count half squares and see if you can work out. But we want you to see if you can work out the areas of each of these shapes. This one is actually exactly the same as this one over here, so we won't do both of those. Pause the video and quickly see if you can work out the area of each of these in centimeters squared. Okay, so this one over here, very easy, 9 centimeters squared. All right, it's actually 3 times 3. We could count them, or we could just multiply 3 by 3. This one over, let's go to this one next. This one's quite easy because we can count all the whole squares first. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're 12 whole squares. Now all the rest of the squares are exactly cut in half. So I'm now going to count, I'm going to add 1 each time I count 2. 13, 14, 15, 16, 17, 18. All right, this one over here has an area of 18 centimeters squared. Okay, and then this one over here is a little trickier because there are not too many whole squares in this one, but let's just try and count the whole ones first. All right, we've got 1, 2, 3, 4, 5 whole ones. All right, now this little piece that's been included here, all right, looks to me to be about the same size as that little piece that's been cut off there. So we're going to count this as a whole one, all right, but we're going to say, right, we counted that little piece to make up for that piece. Okay, all right, and the same over here. This one over here, all right, is just short of that little piece, but that little piece that's short we're including over here. So we're going to count all of the ones that we've ticked as whole ones. All right, and lastly, maybe the same over here, because this little piece looks to me to be about the same size as that little piece. All right, and then again over here, all right, this little piece that we're leaving out, all right, we're actually including over here. All right, so we're gonna count this as a whole one as well. All right, now these last bits, this little piece over here actually looks to be about the same size and shape as that. So in other words, together we're going to count this as 1. Together we're going to count that as 1, together we're going to count that as 1, and together we're going to count that as 1. So let's see what we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, I'm going with 13 centimeters squared. It's a bit rough, it's a bit of a guess, and we'll see. Okay, right, now what we want you to do now, we want you to try and count area, and these ones are a bit easier to count. We're going to try and count the area of the squares, all right? And to fill in the table on page 19 of your workbook, right? So we'll do the first one together with you just to make sure that you understand what we're doing. So we're going to work out the areas of these squares. So this is a 1 centimeter squared, and this is 1 centimeter squared. Let's just go to the table and show you, all right? 1 and 1. And then the area of the square on the longest side of the triangle. Now the longest side is this side. So now we want the area of this square, okay? And the area of this square, as an area, well, it's made up of half a square, half a square, half a square, square, and half a square. 4 halves, it's actually 2. Right, so we're going to write down 2. Let's do one more together. Let's do number 2 together. So on this side over here, this little triangle, we've got 1, 2, 3, 4 squares. And on this side, we've got 1, 2, 3, 4 squares. Let's see if we can count how many full squares there are on the big square on the side here. Well, these are easy. 1, 2, 3, 4. This is a half, and that's a half. So together they make 1. A half and a half, they make 1. A half and a half, they make 1. And a half and a half, they make 1. So 1, 2, 3, 4, 5, 6, 7, 8. All right. So this one's actually got an area of 8. All right. So what we're going to ask you to do is to fill that in. And we are going to ask you to look for a pattern between these numbers as you go down. So basically that's going to take you quite a while. So we're going to pause the video and we're going to let you just try it, and then we will let it play again and we'll go over it. Okay. Okay, so let's look at this next one. Well, we've got, we haven't drawn in the square on this side, but this one is 3 times 3, this one's 9, and this one's also 3 times 3, it's 9. I'm going to quickly try and draw in this square, and it actually is going to go up there, and there, and there. Okay, all right, and if we count these up very carefully, you'll see that we actually get 18, and the reason I know we're going to get 18 is because that's exactly like the square that we did over here. All right, this one over here on page 16. So this is 18. All right, so number 3 is 9, 9, 18. All right, let's look at number 4. Okay, number 4 is 1 and 4. Right, now this is harder to count, but let's just see. We've definitely got a full square here. All right, and then we've got this piece and this piece, I think are going to make one full square. And this piece and this piece are going to make one full square. This piece and this piece are going to make one full square, and these two are going to make one full square. 1, 2, 3, 4, 5. So 4, 1, and 5. Right, let's do number 5. 5, I think, is a little bit easier. We've got 1. Maybe it's not easier. And we've got 9. Right, now, let's have a look. I think this piece and this piece are going to make 1. Okay, so I'm just going to put a dot because I've counted that piece. We've got 1, 2, 3, 4. I think this piece and this little piece are going to make 1. All right? This piece and this little piece are going to make 1. And this piece and this little piece are going to make 1. All right, now I think this one and this one are going to make another 1, and this one and this one are going to make another 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's write that down. 1, 9, and 10. Okay, and then number 6. We've got 4 here, we've got 9 here. And previously we actually did count this one. I'm going to scroll back up and just remind you that that was 13. Okay, so 4, 9, and 13 for number 6. Let's do number 7. We've got 3 times 3 here, that's 9. We've got 4 times 4 here, that's 16. Right, let's see if we can count all the squares in here. Okay, so we'll count the full ones first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, now we're just going to have to try and see this one over here. We've only got a little piece, but I think that little piece combined with that piece will give us 1, so it's 14. This one's missing a little piece, all right, but over here we're including a little piece, so I think that'll give us another one. That's 15. This one's missing a slightly bigger piece, but we're including a slightly bigger piece, sure, over here. I think we had 16, but we'll count them again just now. This one we've got sort of less than half a square, but here we've got a bit more than half a square. I think those two are going to make a square. Excuse me. I think this piece, this one here with that little piece there. This one here maybe with that little piece there. This one here maybe with, let's have a look, that little piece over there. This one here maybe with that piece. And this one here maybe with, sure, maybe with that piece. Okay, and then maybe this one here, just missing a little piece. Where are we counting another little piece? We've got another little piece over here. All right, and then this one with that little piece, and this one, sorry, that little piece, and this one with that little piece. I think, let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25. So, all right, 16, 9, and 25 for number 7. Right, number 8. We've got 4 and we've got 16. Right, let's see. It looks like these numbers are adding. So let's see if we can identify 20 squares inside here. So 1, 2, I'm going to count that one. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. Now, this one here is missing a little piece. I'm going to count it, and I'm not going to worry about that bit there. So it's 13. This one here is just a little piece, all right? And so I think it will go with that piece, will go with that one to make another one. Right, this is just a small little piece, which I think will go with that one to make another one. And this one here will go with that little piece there. Right, likewise this one with that piece, and this one, all right, maybe with that piece. Okay, and then this one with, say, that piece. All right, and then we've just got this one, which here I think can go with that piece. All right, let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, we seem to have found 20. Let's see if that's, so we had 4, 16, and 20. All right, let's do number 9. Okay, our last one. We've got 1, 2, 3, 4, 5. By 5, that's 25. This is 1. So we may be looking for 26 squares in here altogether. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. I think this with that will make 17. This with that piece over there will make 18. This with that piece over there will make 19, and this with that piece over there will make 20. Okay, so then we've got 20. This with that piece, 21. this with that piece 22, this with I think that piece 23, this with that piece 24. I think I'm missing one somewhere. We should get 26 if we do it carefully. We should get 26. So 25 and 1, 26. All right, now what we should notice here is that every time the areas of the squares on the sides of the triangle make up the same, when we add them together, they make up the same area as on the longest side of the triangle. And this is what Pythagoras' theorem says. And what it says that the two sides that make the right angle squared and added together equal the longest side squared. So notice over here, little g squared plus little b squared equals a squared. The full name for this big triangle is BAG with capital letters. What we do is we use small letters for the sides opposite. So just to go and have a look at this one, capital M, small m, capital K, small k, capital N, small n. Right, so what Pythagoras' theorem says is if we take the two sides that make the right angle, the k and the n, and we square those and add them together, then we get the third side squared. Okay, right. Sometimes we don't get exact numbers for our answers when we work out the lengths of sides. All right, and this is a great time to introduce you to what we call irrational numbers. Okay, all right. So sometimes we get a number that works out very nicely, like 5, all right, or even 7,5. That's what we call a rational number. It's a ratio number. Any of those numbers we're able to write, okay, as a ratio of two whole numbers. When we get something like the square root of 57, this number never ends and never repeats. And it cannot be written as a ratio of two whole numbers. It's called an irrational number. But we would just round it off on our calculator. Okay, so what we're going to do now, we're going to work out some missing sides. We're just going to finish these and then we're going to let you try some for homework. All right. So this little side over here is going to be little b. All right, because it's opposite big B. All right, this little side is little c, and this little side is little a. Now we're going to write down Pythagoras' theorem every single time. We are always going to add the square of the two sides which make the right angle. All right, and that will be equal to the square of the third side. And that'll give us an equation. And we love equations. All right, so let's have a look. In this one, we've got the two sides that make the right angle are c squared plus a squared equals b squared. Okay, that's what Pythagoras is going to be in this particular triangle. Okay, these are the two sides that make the right angle. That one there and that one there, they make the right angle. All right, when we square those and add them together, we get the square of the third side. Okay, so now let's fill in what we know here. We know that c is 6, so 6 squared, a is 3, and that will equal b squared. Excuse me. So 36 plus 9 is b squared. B squared is 45. All right, so now we're going to use our calculator to get our final answer. All right, and it hasn't told us what accuracy to give this to, but we'll give it to 1 decimal place. So we're going to work out the square root of 45. Okay, and our calculator does that, but if we put it in decimal form, it's 6,7. All right, so B will equal 6,7. Now, it is really important that we give the units, if there are units. This one says that these units are in centimeters, so B is 6,7 centimeters. All right, the longest side, remember what we learned about triangles last term? The longest side's got to be opposite the biggest angle. And the biggest angle is 90 degrees, always in these triangles. We can't have another angle bigger than 90 degrees, because remember, what do the angles of a triangle add up to? 180 degrees. So if we've got a 90-degree angle, we can't have another 90-degree angle. Okay, it doesn't work like that. All right, let's have a look at this. Excuse me, this next one. Okay, so the two sides that make the right angle, 4 squared plus 11 squared, that'll equal the side opposite the right angle. It will equal, now we can call this little l squared. All right, so now we're going to solve for this. This is 16, this is 121. So little l squared is actually 16 plus 121, it's 137. That's l squared. We don't want l squared. How do we get rid of squaring? We square root both sides. So let's look at the answer to this. The square root of 137. And we get 11,7. 11,7 what? All right, well, the units in this question are centimeters. So it's 11,7 centimeters. Okay, right. We're going to end today's lesson there, and we're going to ask you to try the next few pages for homework. All right, remember it's always the two sides that make the right angle that are going to square and add together to give us our third side. All right, have a great day, everyone. We look forward to seeing you next time.